Hi guys, so I'm going to talk about the possible designs we can have for our MedMotion device. So as they previously discussed, we need this to rotate the cells about a fixed axis. So this is our preliminary design, which is similar to that seen in the electronic version on the previous slide. But in here, where the previous version had electronics and a battery, we will have a more complex gearbox with a very large gear reduction as seen here. So let me go into more detail a little bit. So if we use a torsion spring, which we plan on doing for our first build, our main wheel, seen here and here, will only be able to spin 1.5 or 3 revolutions over an entire 3 to 7 days. So to translate that and make it effective, we need to implement a very large gear reduction and a timing mechanism. So our very large gear reduction is seen here and here. So the first one goes to a timing mechanism, which is similar to that used in MAE 3, except it's a little more sophisticated, and instead of using gravity, it uses the potential energy of a torsion spring, and it's called a Swiss escapement mechanism. This is what you would see in a wall clock that you have to wind every week or something of that type. This second gear reduction here goes from the main wheel to the output shaft, which is set to rotate at 8 revolutions per minute. So as you can see, we're going from 1.5 revolutions over 3 days to 8 revolutions a minute, and the balance wheel oscillates at 5 oscillations per second. So we have to deal with very large gear reductions in here, which will be discussed in more detail later. So now the balance wheel, more specifically, I'll go into detail here. Here's a video of it working. So this area, the escapement mechanism, is exactly like an MA3, but now instead of a pendulum, we have this oscillating what's called balance wheel, which just works on the same principles that we learned in dynamics. It's the square root of k over the moment of inertia about the wheel. So it's a very simple, very common mechanism used in clocks. And this we plan on buying from a clock manufacturer because it's such high precision tooling that we do not anticipate to be able to recreate it ourselves. So we will buy this. They oscillate, the ones we have found oscillate at 5 Hertz, which allows us to have a relatively, it's a large gear reduction, but it could be a lot larger considering a lot of these for the nicer clocks oscillate at closer to 10 Hertz. So we've reduced that by half. That's it for the balance wheel.